Okay, this is Algebra 2, Lesson 25. Now I'm going to give you the code right off the beginning. If you don't want to listen to this video, then you don't have to. However, your code for this video is you need to put the number 369 on the top of homework number 23. 369 on the top of homework 23. Now this lesson we're going to talk about monomial factoring, cancellation, and parallel lines. So let's talk about factoring. What is factor? The book goes into this long history, and I'll read it to you. But basically, it says the Latin word for maker or doer is the word factor. From this came the Old French word facteur, which led to the Middle English word factor. In modern English, we use the same spelling as did the ancient Romans. And in mathematics, the meaning is very close to the Latin meaning of maker or doer. So if we multiply 3 and 2, we get 6. 3 times 2 equals 6. So we say that 3 and 2 are factors of 6 because we can make 6 by multiplying these numbers. If we can make an expression by multiplying 2 or more other expressions, we say that each of the expression that is multiplied is a factor of the final expression. So let's look at the middle of the box. This is a page of the lesson 25. It says a factor is one or two more expressions that are multiplied to form a product. So look at that example. It says when we multiply 4x and ax plus y, we get 4ax squared plus 4xy. So we say that 4x and ax plus y are factors of 4ax squared plus 4xy. So when we write a sum as a product of factors, we say that we are factoring. So let's look at this one, this example on the board. We've been given a sum and asked to write this expression as a product. So we first begin with parentheses, right? Then we say, what's the greatest common factor that each term has? I see a 4 and I see an x. So what we're doing is we're taking the first term and we're factoring out or dividing this. We simply get ax. So what's left here? Ax plus, when we take the second term, 4xy, and divide it by 4x, we simply get y. So factoring this, we get 4x times ax plus y. And to see that we have factored expression by factoring, we can check our work by simply multiplying back into the terms. And what is that called? It's called distributing. It's called the distributive property. So if we wanted to distribute this back, we could, and we would get that same answer we had at the beginning. So let's look at another example. Let's look at example 4, x squared p squared k minus 6k squared p 4x. So the first thing we do is we look at the two terms and say, what is the greatest common factor they have in common? Well, I know a 2 can go into both of these. We have x to the first power. We take a p squared. And and then we can take a k. So what do we have left? So we take an x, this becomes 1. We take the whole p squared. We take a k, and we take a 2, this becomes 2. So we're left with 2x on this term. Over here, we take a 2 out. We're dividing by this. Divide by x, that goes away. Divide by p squared, this becomes p squared. And then this k goes away. So I'm left with 3p squared. Oh, sorry. Yes. Oh, this is a k squared here. So I have a k in here. Okay? So that's simply what factoring is. And we can check it by simply multiplying this out by each term, and we use what's called the distributive property, and we'll see that it works. Let's do another one. Factoring is so much fun. So we have 4x squared y minus 2xy plus 10xy squared. We say there's 3 terms here, so whatever we factor out, we have to factor out all 3 by. So what's the greatest common factor that they have in common here? Well, I know I have a 2, I can take out x squared x, so I can take out x, and I can take out a y. Then I just put my parentheses. So if I divide this by 2xy, is what I'm doing. What do I have left? I have 2x minus 1, because these all cancel out to 1. Then I've got a 1 here and a 5. This cancels, and this becomes a 1. So I simply have minus 1 plus 5 times 1, or 5. Oh, 5y. And I don't have any like terms, so I can't combine them. Had this been just a y, then I could combine my negative 5 and my positive 5. Okay? Now let's look at cancellation. We say that multiplication and division are inverse operations because they undo each other. So if we take 7 and we multiply by 2, then we divide back by 2, we're going to get 7. They undid each other. We multiplied by 7 and then we multiplied by 2 and then we divided by 2, and we got back to 7. So the result is the beginning. So could it work for anything? Yeah. Could be decimals, it does the same thing. So let's look at this one. 4.062 times 3.0176 all over 4.062. Well, these two cancel out, and I'm left with 3.0176. The only time cancellation is possible when both the numerator and the denominator are products of factors. Okay, if there was a plus sign between here, we couldn't have done this. So let's look at an example. If I have 4 times x plus 2 over 4, can I cancel? Yes, isn't this a product of 4 and that? That means multiplication. That's what product means, yes? And down here, isn't this 4 times 1? So these can cancel out, and I simply have x plus 2. Now let's look at this next one. If we have x plus 4 equals 4, well, this goes together because of that plus sign. So I can't cancel. This is not a product. This is a sum. So these 4's cannot cancel out. That would be wrong. So it's simply, you have to leave it in that format, okay, in order to cancel out. So let's look at this one. What if I had 4x plus 4 over 4? Well, each term here, I can factor out a 4. I'm left with x plus 1 over 4. Now I have a product up here and a product at the bottom, so this simply becomes x plus 1. So next we'll use cancellation, but we'll stop right here and this will have part A and a part B.